Hello, welcome back. So in this video, we talk about rectilinear motion, explaining the fundamental concept if your foundation is not so strong for physics. So this video is for you. So this chapter is talk about rectilinear. The word itself, linear, it means that any object or any particle that moves in a straight line path. So it can be any direction. Okay, let's get started. We learn on the displacement, speed, and acceleration during our foundation or the pre-university courses on physics. Okay, I'm going to talk about three fundamental concepts before you're going to do well in the future questions. So which are the scalar versus the vector quantity, discrete versus continuous, differentiation, and integration. So the first concept, scalar versus vector quantity. So scalar quantity, just focusing on the magnitude, which is just the number. Vector quantity cares about both the magnitude and the direction. So let's look at some example. How far from your home to your university? We just care about the distance from your house to the university. We might not so care about the direction. So this is a scalar quantity. Next, enemies are coming from west at 2 km away if we were playing games or look at some movies. So we not just only focusing on the distance of the enemy, we also want to know which direction are they coming. What's the temperature now? And we just care about the temperature, for example 30 degrees Celsius, and we not care about the direction. I got slapped on the right face. So I got slapped, we're going to care how hard it is, what is the magnitude of the force, and whether it's on the left face or is on the right face. Okay, how big is the house? It can be in terms of area or volume. Where did the hot girl go? For example, you came across a hot girl and then you want to approach her. So you ask a friend, oh, where did she go? Not just care only the distance, you also need to know the direction in order for you to approach her. So look at the physical quantities we have. For scalar quantity, we have length, area, volume, mass, density, temperature, pressure, energy, work, and power. All these quantities are focusing just on the number. Whereby vector quantity examples are displacement, velocity, acceleration, momentum, force, magnetic field, and electric field. Okay. Let's look closer to an example. Because in this chapter, we're going to look at the distance and displacement. That's the core concept of it. So let's say your house is a blue color one. And you wanted to go to your friend's house. And you walk to your friend's house. And the distance between your house and your friend's house is 3 meters. And next, you're going to travel from this house to another friend's house. Then you walk. You got 4 meters. The distance is it. So what is the distance that you travel from your house to the green house? Is it the 3 meters plus 4 meters? Yes. So is this total distance 7 meters. And what is the displacement? So displacement focusing on the initial position and the final position. For this path, we can represent it in another way. It's equivalent from the blue house that you travel straight away to the green house. And that's the displacement. We're just focusing on the initial position and the final position. Let's say it's a 5 meters. Therefore, the displacement is 5 meters. Another example. Let's say a ball bounces. Of course, it travels quite a number of distance because it bounces up and down. But we don't care about the displacement. When we talk about displacement, what we focus on, two things: the initial position and the final position. In this case, the distance between them is 20 meters. So therefore, the displacement of the ball travel is 20 meters. The second concept, we talk about discrete versus continuous. So why we're not going to talk about this concept? Because we deal with differentiation and integration, it deal with the continuous. And in most of the engineering practical questions, we also deal with continuous. All right, let's see. Two graphs of same value, but it represented in two different ways. The first one, discrete, you can see it's just up and down, and down. And this is the curving path. So how we plot the discrete path? Let's say we did an experiment, then we got the value with point 0, 1, 2, 3, and 4. Then we draw the straight line and join them together. And as we find a point in between this line, it might be close, but it is not so accurate. But in continuous, when we find at any point, it can be as close or it can be as accurate as a real value. So that's why we deal with continuous. This is one of the reasons. Okay. Another reason is when we want to measure in terms of the gradient. We learned that it's the change of y over the change of x. Whereby continuous, if we want to find the gradient, it can be along at any instant, at any point, we want to find the gradient. As any point, let's say a point, so the distance change of x is very, very small. Therefore, we can write in this expression the limit where the change of x approach 0 because the change of x is just very small. And therefore, from this expression, we can write as dy dx, the differentiation. For discrete, if we want to measure the gradient, we pick 2 points, any point, and then we find the gradient. Just simply y2 minus y1 over x2 minus x1, and we find the gradient. And we notice that the gradient along this line will be constant. At any point, the gradient will be constant, the value of the gradient will be constant. Whereby continuous, let's say we pick a point, and the gradient will be the tangent line at this point. We differentiate it, and then we substitute the value of x is 1, the value of y is 5, and then we got the gradient. Okay. So let's look at the differences between discrete and continuous in terms of velocity and acceleration. Constant velocity versus the velocity as a function of time. Same for acceleration, constant acceleration, and acceleration as a function of time. Okay. Constant velocity, let's say a particle it moves at a constant velocity, means along the whole path, it just travels at the same velocity, which is 20 meters per second. If this particle is moved as a function of time, that's why we write v in a bracket of t, because it's in terms of the time t. So that's why we have the function expression in terms of t as well. So we notice that if we point at any value of the time, okay, so let's say is that when the time is 0, we substitute 0, then we got -5 meters per second. And when let's say we put when is in terms of 1 second, so 2 minus 5, we got -3. So we notice that the velocity changes at every second or every unit of time. So that is different between the constant and the velocity as a function of time, which is continuous velocity. So it changes every moment. Same for acceleration, -5 meters per second square. Acceleration in terms of the time is -t squared plus 3t minus 6. So we substitute any value of time, it changes the acceleration along the time. So it is not constant anyway. So that's why we has a function of it in order to find the velocity or the acceleration at that moment, the specific moment of it. The third concept, we're going to talk about differentiation and integration. This is very important because we're going to deal with how we differentiate to get the velocity acceleration. Alright. Firstly, we have displacement, velocity, and acceleration. the relationship between all these three, they are related. Where displacement go to velocity, we need to differentiate in terms of time. We differentiate the displacement in terms of time, or in other way, in respect to the time. And velocity goes to acceleration, we differentiate in terms of the velocity. So on the top, we just differentiate. When from acceleration goes back to velocity, we need to integrate it in terms of the time, or in respect to the time. And velocity, when we want to get back to displacement, what is it? It is integration of the velocity in respect to the time. And this is the relationship that you got to know, because it's very simple. From this one, jump to here, differentiate, and integrate. So right now we look at some examples on how do we apply in questions. Alright, let's try. Given the equations of motion of a ball is represented as the function of time s equal to t squared plus 5t minus 3 in terms of meter, and time is in terms of second. Find the velocity and acceleration when time is equal to 2 seconds. So it's given the displacement, and we need to find the velocity and acceleration. But how? Then we need to differentiate this equation in respect to time. Okay, velocity, we differentiate the displacement in respect to the time. So t squared, differentiate 2, bring over, it becomes 2t, and 5t, and this is 1, bring over is times 1, and then we minus it, so there's no more t. So 2t plus 5. And this is the function of velocity only, but we want to find the value. Then we have to substitute the value given when is it at 2 seconds. So we substitute 2 here, and we got 9 meters per second. So for acceleration, it's the same. If we want to get the acceleration, is differentiate in respect to the time of the velocity. So we use the velocity function and we differentiate it. If we differentiate this function, we got just 2. Therefore, the acceleration is 2 meters per second. Since this equation is not in terms of the time, so acceleration is constant at any moment. So it's just simply 2 meters per second squared. Alright, I forgot the square here. Okay, let's look at another example. So you can pause it and try yourself if you want to. Given the acceleration of a rocket can be represented by a equal to 5t plus 1. So find the velocity and displacement when time is equal to 1 second. Assume that the initial velocity and the initial displacement is 0. Okay, let's see how we do it. If we want to find the velocity, we need to integrate the acceleration in respect to the time. So if we integrate 5t plus 1, we got 5 over 2 t squared plus t, and with a constant. Alright, so that's why they give it the initial condition, the initial velocity and the initial displacement, in order to eliminate or find the value of the c constant, this one. So given initial velocity means when the time is equal to 0, the velocity is equal to 0 as well. And we sub this value into this equation. So 0 equal to 5 over 2, 0 plus c. Therefore, the value of c is simply 0. Now right now we can eliminate c, and we got the final function of velocity in terms of time. Alright, so what we right now want to find is in terms of the value. So we need to substitute the time is equal to 1 second here, 1 is substitute. And finally we get 3.5 meters per second. And we do the same to find the displacement. So how do we get the displacement? We integrate what? The velocity, yes. So we integrate the velocity in respect to the time. So we got a new function, but we got a small c here as well. Alright, so in order to find the value here, we use the initial displacement is 0, and we substitute the time is 0, displacement is 0. We also get that the c is equal to 0, so we cancel this term. And when time is equal to 1 second, we substitute the value, and we got the displacement is 4 over 3 meter. Alright, okay, And these are the fundamental concept of the rectilinear motion. On next video, we're going to talk about the real examples on how we solve the questions on the real questions for the rectilinear motion. Okay, see you on next video.